All right. So I wanted to start today's conversation by exploring some of the stuff that we went over last week. I know what you're going to ask, Seth. I'm sorry I didn't have an opportunity to post a website today. We'll continue to explore that information as we go through the next hour or so. Okay. Today is going to be an amplification of the rig that we've been working on. We'll get back to what the outcome is going to be for this week, so we'll get back to that a little bit later. I just want to kind of jump into the content. And some of those other details we'll kind of shuffle out and we'll figure them out as we go, okay? So I wanted to start off just by talking about some concepts that I think are important to revisit as we go through this process of rigging. Rigging is a challenge, and I think everyone's starting to understand the challenge that's in front of them. This is a very, 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 very technically demanding art form, okay? It really shouldn't be a surprise to any of us that out there in the real world, the guys and gals that are doing this type of work are called technical directors. Because as you understand from your experience over the last week, this is crazy difficult. Well, it's not that it's crazy difficult, this is crazy technical, right? Katie's like, no, it's crazy difficult. It's stupid hard, okay? If you really hate this, just bear with me for a couple, like for this week and for next week, and then we'll be done, and we won't come back to this again, okay? We have to do this module. It's part of the program. It's part of the components that we need to kind of, at the very least, be exposed to. So just bear with us for a couple more weeks, and then we'll be done, and we'll move on to some fun things, okay? We will get to more traditional animation here very, very shortly. I think all 3D artists at least have to have a basic fluency with their rigging tools, because out there in the real world, you might get asked to do something that you're not historically categorized to do. I can't tell you how many times I've been asked to do something outside of my normal job description. So at least having an understanding of the process and the workflow, I think, is really, really, really important. What you do with it after our conversation this week and next week is up to you. I would encourage you to get into rigging. Rigging's a lot of fun. I think for me, it's an exciting process because I finally get to see my stuff come to life to a certain degree. So it's a really cool art form, but I'll be the first one to say it is hard. There are a lot of moving parts. So conceptually, last week we talked about two major things, right? Skeletal systems and then binding, okay? In the binding section is probably where you guys started to go, what? Because binding can be difficult. And the process of going and editing all your vertex map information is laborious, is it not? Yeah. You have to check almost every single joint and understand which parts of your mesh are being influenced by the rotation of that specific joint. So I wanted to start off today's conversation just by revisiting this idea, but in a more simplistic fashion. I think last week I may have overreached to a certain degree, and I started to roll out some really interesting and advanced concepts in an already interesting advanced arena. So we're going to dumb it down to a certain degree and work with some very simple shapes and just kind of focus on the idea, the concept. So for me, all simple shapes and ideas and concepts start with very simple models. And I think I'm just going to simply start with a cylinder. Okay, this cylinder is going to be kind of the foundation for our entire object. And this actually, if I want my little cylinder here to be sitting on what I'm going to call the ground, okay, on the ground. Now you could eyeball it, okay. There's nothing that says you can't go into your polygonal selection set and just move it up like that. But this gives us a really cool opportunity to talk about how Modo can extend its tool set with some scripts. And I'm all about scripts. I like using scripts to do some very cool functions for me, because what I just did there is you can move things by hand, but it definitely lacks a certain degree of accuracy. And out there in the Modo world, there's a number of third-party scripts that are written by, actually, some of them are written by the guys down at Loxology, but others are written by industry professionals around the world that extend the Modo system to do some very specific things. You can find a whole library of scripts on the Loxology website. They're pretty cool. And if you go into the share section of the website, let's see. They've shuffled this around a little bit. Here we go. It's scripts over here. And these scripts allow you to do some really neat things. I'm pretty amazed with some of the stuff that these scripts can allow us to do. At times, they're relatively easy, or they're relatively simple scripts that do one thing. Others do a whole series of things. So start to peruse these, get to know them. Some of them are really great. There is an artist, and I'm not 100% sure if all of his stuff is on here. Let's see. I don't think they are. There's an artist called Seneca Menard, and Seneca is one of the lead. Yes, ma'am.
Are they going to be animating our skeleton model?
Yes.
Okay, just
Yep, absolutely. Seneca Menard is one of the lead 3D modelers and riggers down at id Studios. Does anyone know id? id is kind of a big game studio down in Texas, Tejas. Does anyone know what games id has made?
how do you spell it?
ID?
Oh, ID.
Does anyone know the id games? You know them. Doom. It is most famous for the Doom franchise. And they've also gone on most recently to do Rage. And I'm really excited about what their next project is going to be. Anyways, he works down at id. He's a big Modo user. He's been using Modo seemingly since day one. And he has a whole series of really great scripts that extend Modo to do some pretty amazing things quickly. Because when you're a game artist, it's all about getting through the modeling and texturing phase as fast as humanly possible. Okay? So I don't remember the name of his website off the top of my head, so I'm just going to do a Google search for Seneca Menard. There we go. And he has his, here we go. Seneca's Modo scripts. They are kind of old at this moment, but there's a bunch of them. And if you look carefully at each one of the little thumbnails and the description that's associated with this with all these scripts, you can get a really great understanding as to what the function of these scripts are. Now, I'm not going to go through all of them. There are rock stars in this list. There are others that I haven't even downloaded and played with. Some of these scripts have gone on to be first-party tools inside the application, like mesh cleanup. Do you guys know the mesh cleanup command inside of Modo? That started off as one of Seneca's scripts, okay? And they said, this is so awesome, we're going to make it a first-party tool. One of their scripts, however, down here at the bottom, or somewhere in here, I don't remember where it is, and he has a bunch. And there, like I said, there are a bunch in here, so check it out. Extrude along edge path, that's another Rockstar one. Well, I don't know where it is. Lazy select is something that's now a first-party tool, which is kind of cool. Here's mesh cleanup. Well, I don't remember where it is in here. Quick pipe, that's also another really great one, FYI. Rest on ground. There it is. Okay, so this is one of those things where you're like, I just want to move my box to the ground, right? And I want it to do it auto-magically for me. I don't want to have to fire off the move tool. I don't want to have to do, kind of figure out where in my scene to place all this stuff. This script kind of does a lot of the heavy lifting for us, which is kind of neat, okay? So when you download it, you're going to get a little piece of Python, okay? An actual physical Python script, and we can very quickly apply those scripts inside of our scene just by, let's start with a selection, just by going up here to System, and we're going to do Run Script. Okay, when you hit the Run Script button, it's going to open up a Finder window, and it's going to ask you to find the location of the script that you want to fire off. And I have a folder on my computer called Scripts, obviously. So this is where all my scripts are, and there's restonground.pl. So if I just click on Rest on Ground and hit Open, boom, you can see that my mesh has automatically been aligned and moved to the correct orientation of the scene. It's just that easy, okay? Scripts are an excellent way to extend Modo to do a lot of things very quickly, okay? And definitely check out Seneca's stuff. He is a master, and he's got a lot of really good scripts. If Seneca is listening to my live stream, can you please update all of your scripts to 701? Pretty please. Yes, sir.
I was trying to align my spaceship to start off on the ground like that, and I went to the align work plane to the z-axis instead.
Yeah. So the issue that we have when running I wanted to do this polygonally. I didn't want to move my item, okay? And the problem that we have often, especially with objects like this, is that I can align one polygon to my work plane. But if you notice carefully what happened on my cylinder here, all of the polygons on that contiguous shape were moved up to match the location of the work plane, okay? So that's the big differentiating kind of element in here, is that the work plane, with the default tools instead of Modo, it would have moved just the one polygon that I had selected. It figured out all of the polygons that were selected in my cylinder and moved them all up as one rigid body. So that's an important point. Okay, it's cool. It's good stuff. Check out Seneca's stuff. You'll geek out. Some of them don't work, and some of them don't work. If you look at the website, yeah. They download for Modo 2 and Modo 3. So it's been a number of years since he's updated some of these scripts, which is why I would really love for him to go through and debug all this. But it's cool. It's cool. Shoot, for stuff that's for free, I love it. And there's just so many of them too, which is crazy. FYI, super UV tools, they do not work in 701. Trust me, I've tried. I wish they would work in 701 because they're awesome. So anyways. Okay, so let's get back to the topic at hand here. And I want to spend some time just talking about how we can use this process of skeletal joints, and more importantly, these vertex maps to influence the movement and the rotation of very specific parts on our body, okay, or on our characters. Over the course of the last week, I talked to a lot of you guys in my office hours as we troubleshooted and tried to figure out this process of rigging. Come on in, Alex. Good timing. We just now get into the important stuff. So, and one of the kind of the big concepts that I see people running into and having a big problem with and having troubles with is understanding how these vertex map deformers are being influenced, or are influencing the rotation of certain areas of our character. That's the big hitch. It's like, what in the world are these little red and pink dots mean across the surface of my mesh? How are these actually influencing the rotation of the joint? So we're going to simplify it just with this little cylinder here, and we'll start rocking and rolling. So I want to create the world's simplest chain here. So I'm just going to go into setup mode, go to the setup tab, and we're just going to start rocking and rolling with our skeleton tools. And I was messing around with this before, so I'm going to turn off my symmetry here. Go. And I'm simply going to create a 3-chain system. That's it. That's the extent in which I'm going to do all of my skeletizing. Is that what you used last week, Kaylee? Skeletizing? Skeletization? I like skeletizing. It's kind of a fun word to say. Okay. So one of the things that on the skeleton side of things, you have to pay really close attention to the placement of all your skeletal joints before you bind it to your mesh. Now this is kind of a point of no return, okay? So you have to have your skeleton just like absolutely perfectly dialed before you bind it to any sort of polygonal cage, because it's very difficult to remove that bind, and you either have it bound to a skeleton or you don't have it bound to a skeleton, okay? So you can't really edit the location of your skeleton if there's vertex map deformers applied to that skeleton, okay? Any correction requires you to completely remove all of those deformers, okay? So I have some additions, some editing that I have to do here, okay? I have to move these elements around and get them where I want them to go. So let's see, I think I'm just gonna, let's do this. Let's do 2 work plane, oops, let's not do that. Yeah, let's just move it back. And shoot, I want to move it back with a little bit of accuracy. So I want to turn on my snapping. And I like working with my snapping tools. The snapping tools allows me to gain a little bit more control. If you hit the F11 key, or not the F11 key, hold on a sec. Yeah, give me 2 seconds. I gotta return the values of my function keys here. Use all, yeah, use all, okay. There we go. I win. Aha, there we go. The F11 key on your keyboard is going to pop over your snapping palette. It's kind of hidden inside of the setup tab, so F11 is a good one to remember. That's a global keyboard shortcut, by the way, that will always pop over your snapping controls. I use snapping a lot, especially the vertex snapping, so snapping to specific pieces of geometry within the scene. And then I also do a lot of grid snapping as well. And I think moving my little joint structure, my skeletal structure around here, provides us with a good opportunity just to turn on a little grid snapping. There we go. And now when I use the move tool, there we go, and I have the wrong thing selected here. There we go. Now I can move it with a little bit of precision. Yeah, I'm happy with that. All right. Snapping is an on-off toggle thing, so just make sure you turn it off when you're done. F11 will give you all of your snapping tool options. Does anyone remember the keyboard shortcut to do the toggle? X. X. X as an X-ray. Good one to commit to memory, as you're going to be using this a lot. All right, so I got my simple little skeletal system here. And let's stay a little organized and rename all of our skeletal joints, just so we kind of have a nice understanding of the role of these joints in our skeleton. I'm going to name this one root. Okay, it's just a good one. And then we'll just name this one middle. The last one creatively will be top. There we go. Super simple. All right, now that we have our crazy little skeleton here, we're free to go in and bind this skeleton to the actual mesh itself. Now, this is the point of no return, so be very, very careful and ensure that all of your bones are where you need them to be before you go into that process. Now, I'm in the setup mode, right? How do you guys know visually that I'm in setup? Yeah. Hit the setup button if you're not. I'm already in setup, and as you guys pointed out, visually you know that because of the yellow border that's cruising around the outside of my OpenGL window, and kind of the background colors change, get a little darker. They may have changed it. It may have changed it. I'm really happy. If they have, can someone just, is it not working for you? Is it not working for everyone? Yeah. Yours, so is the return key on the number pad, is that toggling it in and out? Good. I'm happy for that, because that was a stupid keyboard shortcut in my opinion. Because myself and a number of other people, you know, I keep my hand when I'm using a mouse right next to the number pad, and I can't tell you how many times I accidentally hit the return key on my number pad and entered into setup mode. That's bad juju. Okay, I don't like that. Okay. All right. So I'm happy that keyboard shortcut's gone. I like physically having to toggle in and out of setup mode by pressing on the button, because then you make kind of like a conscious cognitive, connection that you are in setup mode, and anything you do here is going to be applied to the setup pose. So now that we're in setup mode, walk me through the process of binding my little skeleton here to my stupid little cylinder. What do I got to do?
Testify moving it?
Well, we're going to ultimately test it, right? We got to bind it to the cylinder, right? We have to connect the skeleton to the cage.
Go to the Deformers tab.
Deformers. Deformers, okay.
And then you want to go to the roots of the skeleton.
Okay.
Select the data. And control click on your mesh.
Yeah, shift. FYI, and that's a point that needs to be kind of ironed out. What is the difference between a shift select and a control click select?
In the viewport, if you shift click, you move it. If you control click, you also move it. But in the menu, it's actually different. If you shift click, it's everything from that.
Yeah. This is where confusion kind of reigns, and Mr. Tyre, you're absolutely right. If I was to select my skeleton and hold down the Shift key and click on something in the OpenGL viewport, it's going to select that item in the OpenGL. If we were to do the exact same thing in the item list, check it out. We're going to get a much different result. Okay, so if I was to select all three of those, then hold down the Shift key and grab my cylinder, what does it do? Yeah, it grabs everything in between. So that's kind of danger, danger, danger. Just be very aware of where you are in the interface when you're clicking away. Thus enter the role of the control click. The control click will allow you to individually select items in the item list and add them to your current selection. So if I was to go back to the example that I had before, oops. Also deselect, yeah. So if you hold on the control key, now I can click on cylinder and add it to my selection. Okay. All right. So important parts about this is we got to select the skeleton first, then the mesh itself, and then our little bind command over here in our toolbar will become ungrayed out. Now, a lot of you guys were exploring the different bind types inside of Modo. What's the best one? Heat. Heat is magical. It really is quite good. You always, 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 always want to give it a go on heat first. Sean's shaking his head in disgust because he did smooth distance. And I think he wanted to pick up the computer and throw it out the window. Yeah, it doesn't do a very good job. Well, actually, smooth distance has its role, okay? And smooth distance is one of those things that you should kind of keep in the back of your mind, because smooth distance is going to start to, it's going to figure out the location of a joint, and then it's going to assign all the vertices within a certain distance to be influenced by that joint, okay? In certain situations, that's a good one to have at your disposal, okay? Heat, however, is what you should be using for 95% of the stuff, okay? It's the first option in your mind, okay? I don't know. I really don't know.
I have a good answer to that.
Okay?
Off my head. Because with distance, it's literally distance. It's a radial distance that you set by the follow option. Heat, basically moves between mediums. So it basically just moves across that mesh itself to decide where it goes. So it only goes across the mesh also.
You know, I think for all explanations, if you're really curious about the function of a tool, just consult the documentation. I think the guys down at Luxology have done a knockout job of providing us with some really rock star documentation that clearly describes the function and the role of all of these different commands. Does anyone know where to find the documentation? Help? Then, let's see. There's the inline help, which is kind of cool, okay? But it's not the official documentation. And let's see. But it's probably in there. Yeah. The inline help is a good start. I like the inline help. So rigging animation, applying deformers. I mean, there's a lot of really cool things. In addition, this is also something that's really cool about the inline help. They've embedded videos from time to time in the inline help system. So it's a great way in certain situations to get a small little video tutorial on what that tool or what that comment or what that option is really going to change. And then, let's see. Documentation is in here somewhere. Or not. They're making it a little bit more difficult to download. The actual documentation, maybe it is just activate help. No, I didn't think so. The actual documentation's a gigantic PDF. Well, I'm not gonna sit in here and all right. Okay, so let's get back to it. I'll let you find the documentation. I really don't know where they've linked it from now, but it's in there somewhere. Okay, so let's take a look at what we got here. I've done the heat bind to my skeleton, and things are starting to look exactly how I want them to. One thing that I kind of glossed over last week, and this is a little bit of it's entirely of my own fault. You can change the way your OpenGL viewport chooses to display all of these vertex map deformers, okay? Right now I'm in the setup mode, and you can see the brightly colored objects on the screen itself. If I deselect, however, my skeleton, all of those bright colors go away, okay? And whenever I select a skeletal joint within my system, you can see that those vertex maps pop back on. If you're not getting this, if you don't see any sort of rainbow colors pop in and off your screen when you're choosing to select or deselect any of your skeletal joints, there's a very, very simple OpenGL viewport property that you need to change, okay? So with your cursor in the center of the screen, hitting the O key will bring open your viewport properties. And where we want to go is into drawing and control, and specifically, let's see, where was it? Viewport controls. It is in here. It actually may be on visibility. They have shuffled this entire thing around in 701, and where things were in 601 are now gone. Here we go. It's in active meshes. Active meshes, and just make sure that show weight maps is turned on. That way, when you select any joint in your scene, the weight maps will show up. Okay. You can actually turn them off if you don't like them. Sometimes when you're done with the rigging process, this just kind of gets in the way and you just want to animate your guy, or so turning that off is kind of nice. Okay, so let's do some work here and let's understand what in fact we've done. Now, in my little cylinder here, I had 3 joints, okay? And I think what's important to point out here is that we have 3 joints and then 2 bones in between those 3 joints, okay? You can see the bones sitting in between them. They're little cool little pyramid-shaped things, okay? FYI, if you click on a bone, it will select its corresponding joint as well. So if I click on this one right here, you can see that the root joint is selected. A lot of people, they get confused. They think they were actually adding bones into our system. We're not. We're actually adding joints. And Moto's giving us a lovely little interface element there to describe the connection between all of these little joints. It also makes selecting joints a little bit easier, because now we can just select on, we can click on the big trapezoid looking thing in the center, which is pretty great. Okay. So we have a joint up here at the top that's really not influencing any part of our mesh. It doesn't have any sort of vertex map information applied to it, and that's fine. We always need to have some sort of terminating joint along our chain, okay? So at the top of our skeletal chain here, we got this one, and as you can see, it's not really doing anything within the scene. But the joint immediately above it in its hierarchy, the middle one, is pretty much influencing the top of our cylinder, and then our root joint is influencing the bottom of our cylinder. So let's look at specifically what the system is choosing to do. When we bind any sort of object to a skeleton, the computer's making a whole series of deformers, okay? These deformers are going to allow us to bend and move and scale our object around a number of different or around the center point of our little joint, okay? We get access to all of those deformers in the Deformers tab. This normalizing folder is going to provide a complete list of all of the vertex maps that were generated in our scene. And you can see that we have 2. There's that first one. Okay. And if you start to explore all the items in the deformers list, you can actually see the weight map itself and then the 2 objects that weight map is influencing. Okay, which is pretty great. Okay. Now on your character, you had a bunch of these. On my simple little scene here, I just have 2. This is a great quick way of, or deleting these elements in your Deformers tab is a great quick way of kind of removing the bind from the skeleton.
Does every vertex have to have 100% value?
No, it doesn't have to have 100% value. It just has to equal 100% value.
But I mean, it's like there's no vertex that's not going to have less than 100% value, right? Yeah,
Well, it goes from 0 to 100. 0 to 100. You can go into the negatives. I don't know why you'd want to go into the negatives. I've never done that. The system allows it, so I'm sure there's a master plan here that I'm not privy to. But you.
I just noticed when I was clicking on, when I was painting the weight maps, it's like you rate some of the, it had some of the other one, and then it would add it to a different.
Yeah. So it has to total 100%. It has to total 100%. Yeah, absolutely. We're going to come back to that idea here in a minute. Absolutely. And that's the normalization process. It's normalizing the value, the weight of that vertex across the entire mesh. Okay? So one vertex can't be influenced more than 100 at a value of 100% by more than one bone or joint, excuse me. Even I get into the whole bone thing from time to time, but it's really joints. It's joints. Okay. All right. So let's talk about just kind of visually what's happened to this to our little scene here. As you can see, I'm still in setup mode, so I want to play around with my little character. So I'm going to exit setup mode, and when I exit setup mode, I can very, very quickly start to examine the result of my rigging operation just by rotating my little root joint here. Now, it kind of makes sense why we're getting this entire action at the moment, because I'm rotating the entire chain, right? When I rotate the root joint, I'm also rotating the middle one and the top one, okay? So what would happen if I rotated the middle one? Let's check it out. All right. Now we're getting kind of the hinge effect across my little cylinder. It's very, very basic. Imagine this is like the arm of your character or maybe even the leg of your character. Okay. So as you can see, not all of the vertices are being influenced or rotated by this joint. There are a few down at the bottom that are, well, some of them, actually, to be honest with you, all of them are rotating, but just at different values, right? Just at different percentages. And this is truly what we're doing when we're adding these deformers and these weight maps. We're telling certain vertices to be rotated at a rate of 100% whenever we rotate that joint, right? And other vertices we're telling to not be rotated at all, okay? And then a whole series of percentages in between there. The way the system communicates those percentages is by the color on the vertex weight map. When you see that deep 100% red, that means that vertex has a weight value of 100%. So when I rotate that joint 10 degrees, those vertices are also going to get rotated 10 degrees, okay? Same rotation value.
And that's going to cause some sort of deformities in the rig in your model, right?
Can you say that again? I missed half of it.
It's okay. That's going to cause deformities in your model, right?
Yeah, it can. And this is why we want to go in and start to wrangle this in. We want to edit and control it. Because I want to have the top portion of my cylinder move when I rotate that middle joint, right? I don't want any of those bottom vertices to be moved at all, okay? I don't want any of this stuff down here to rotate and move. So I need to go in and edit some portions of my mesh, okay? All right. Yoink, yoink. It's kind of fun, actually. Twist it. You just hit undo here. You can twist it like that. That's always kind of fun. Yeah, deformers are a lot of fun, and these vertex maps, these weight maps, they're just controlling how much deformation a vertex is going to receive. Okay, so let's talk about how we can go in and quickly edit and control all of this vertex map information, the weights that each vertex is being assigned. Now, we have a number of tools that allow us to do this. I think last week I just kind of jumped in. I showed you the painting tools. But let's look at it numerically, because I think once you understand the numbers behind it, it becomes a little bit easier to grasp and understand, okay? Because at times, numbers are a good place to start, and then we'll talk about the artistic application of those numbers with the painting tools, okay? All right, so I'm going to do all this in setup mode. Whenever you edit your mesh, you want to make sure that you're in setup mode. The performance is going to be a whole lot better. The general experience is going to be a whole lot better. And I think overall, across the board, you're just going to understand that what in the world that you're doing, okay? So I'm going to go into the weighting tab down here. And inside the weighting tab, we have a number of really great tools, okay? Now, the ones at the top are going to give us a really great opportunity to do this numerically, and I'm a big fan of adjust weights. I think it does a great job of allowing us to very quickly go in and adjust all the vertex map values applied to these vertices, okay? So I'm in my item mode, and I got the center joint selected. So if I just jump over here into my vertex selection, notice that the item is still selected. We don't drop that selection when we're in the setup tab, because it's going to allow us to very quickly go in and select some vertices, okay? Let's just do it, let's just do it real fast. And I got to do this from a number of angles as I sit on sit with my Wacom tablet here. Come on, fingers, you can do it. There we go. It's Friday, so. Yeah, I can turn that. Let me just go into wireframe. That way I don't have to deal with this. There we go. Okay. So now I've selected all the vertices along the bottom of my cylinder here. Okay. You can see that vertex selection on the screen, and if I fired off the adjust weight tools, I want to just stop and allow you guys to focus on the values, the numbers that are showing up on top of each one of the vertices, okay? This is Moto communicating directly to us the weight value that this vertice has on that joint, okay? So right now, you can see that there's a nice gradation of values as it goes down each edge row. Oh, FYI, I forgot to mention this, but you can also do, you can use the adjust weights tools in conjunctions with an edge selection and a polygonal selection. So you're not required to select vertices. I think it's just the easiest way to see the values. So there's all the numbers. Oops, okay, there's all the numbers. And the tool options over here allow us to change those numbers, okay? Now we got to be careful. We want to make sure that normalize is turned on because we want to make sure that each one of these vertices has a grand total of 100% influence across every single bone in our mesh, okay? So keep normalized on, and if I just simply left click and drag, there we go, there we go, it's going to reduce all those down to 0, okay? So now when I rotate, let's get out of setup mode here for a second, back into items. Now when I rotate that joint, we're going to get a slightly different result, right? The bottom of my mesh is no longer dancing around as it once was because we've removed the vertices at the bottom of my cylinder from being influenced by that middle joint, right? We've basically have turned them off for that joint, okay?
So with the skeleton, I don't want any other part of the joint except for what's in front of it being affected. Or
Yeah, I think that's a good strategy to work with. Absolutely.
will I want that, or?
Well, I've learned to never say never. Yeah, in the 3D art world, everything is conditional on the object that you're trying to work with. Okay, but generally we want to isolate one joint like the elbow from only really influencing the forearm area. Okay, just this area in here. Okay. All right. There we go. Now we're getting some weird, wild deformation here. Okay, we can try our little, oops, excuse me. We can try our little spinny thing that we had before. We're definitely not getting the cool result that we had. Okay, and that's all thanks to the vertex map information that's been applied to that joint and to its corresponding and connected vertices. Okay. All right. Questions? Everyone kind of understand the basic ideas? Yeah? Okay. Let's talk about some of the other tools that will allow us to do this. I like working with the adjust weights, and let me, as just a very quick illustration of the concept that I was talking about before, you can go in and just grab some edge edge loops here, and adjust weights will allow you to do the exact same thing. Okay. So maybe I want a value, and I'm left clicking and dragging in the interface here, and you can see all those values interactively changing in front of us. So maybe I want that row right there, or these rows in here, it's all these edge vertices, edge loops, to have a value of 30%. So now when I rotate that joint, they're going to move a little bit. They're going to move a little bit. Okay. These up here at the top are moving at a rate of 100% of the rotation value that I'm applying to that joint, right? These in here, so basically these 3 edge loops and the vertices associated with those edge loops are moving at a rate of 30% of the rotation value that I've applied to that joint. Okay? Kind of makes sense? Getting there, getting there, getting there. Okay, let's extend it a little bit. And this is actually kind of cool because often what we want to do is that we want to make kind of smooth transitions from areas that are being influenced to areas that are not being influenced, okay? Because this looks kind of crappy right now, my little rotation. I don't like the idea and the fact that what we've achieved here are these really sharp kind of binds right here, these little folds. That little plane change is kind of ugly, okay? Check this action out. This is actually kind of cool. I'm gonna go back into my setup mode, and I'm going to make some corrections here. I need to change some vertex map information, and I think, let's see, starting from that one right there, I'm gonna grab all of those guys. Okay, I basically want to have this edge loop up here represent the edge of the 100% section, right? So everything above it is going to be rotated at a value of 100% of the rotation of that joint in the center, right? And this bottom edge, so this one right here, I want it to be the border and the start of the 0% section. So everything below it isn't going to be influenced at all by the rotation of that middle joint, right? And I want the computer to help me out and figure out the values in between those two edge loops, okay? Because I'm not about going in and figuring out the math by myself. Come on, who do you think I am, right? No way. I'm not going to figure that out. That's way too much thinking for a Friday afternoon. I'm already thinking about the birthday party I'm going to. There is cake in my future, man. I do most anything for a free t-shirt and for a free cake. Come on. Anyways. So I want the computer to help me out a little bit. And if you remember back to GCOM 402, and if you've taken GCOM 424, we've talked about the role of fall-offs, okay? Fall-offs are the bomb. I love fall-offs, okay? Fall-offs allow us to globally affect a number of different elements based on a very specific pattern. And we can use fall-offs in conjunction with pretty much every tool inside of Modo, okay? The fall-off hierarchy, the fall-off system sits on top of the tool system, okay? So if we apply a fall-off, or if a fall-off is active in our scene, everything is going to be influenced by it, including the adjust weights tool. So check this out. This is actually really kind of neat. I like fall-offs. And I think through the lens of rigging, it plays a really interesting role because now we can globally affect large areas of our model and have the computer figure out the transitions between all of those vertex map weights automatically. Okay. So I'm just kind of framing up my selection in my OpenGL viewport. And at the top of the screen, and they have changed it. I've lost my fall off button, so I'll just go to model and I'll apply it through here. Because you can turn the fall-offs on everywhere. Here's the fall-off tab. So if I grab a linear fall-off, the first area that I click is going to represent 0% influence of the tool. And the bottom of the fall-off, so at the wide part of the triangle, is going to represent 100% influence of the tool. Okay? This is a global parameter, so if I go back into setup, yep, it's still on, and it's in its original configuration. So now when I do adjust weights, look what automatically happens for me. It might be difficult to see. Let me zoom in so you guys can see what's going on. So at the top here, these vertices are 74%, 30, 30, 30, and then 0. Okay? This is a live tool. Let's see if we can do it. I haven't. Say again? Which one did I click when I clicked on linear? I'm sorry, linear fall off. Linear fall. And if you notice as I'm clicking and dragging, I mean, this is just really cool for me because these up here are getting a value of 78%, and then it's doing a small little gradation as it goes down the center. Okay. Now, probably what I should have done initially, let's do this. I'm going to go back into model, and I'm going to turn off my fall off, and back into setup now. I'm going to nuke all of their values just initially, and then we'll start over from scratch because I think it was trying to normalize all these weights on top of their current value. So let's just put them all down to 0. So now we're starting on level ground here, and we'll do the whole fall off thing again. So model tab. What did I just miss it? Where was it? It's in here?
It's right there, above the weights.
Above. Look at this. Thank you. Brilliant. Excellent. Excellent. I love it. Okay, let's do it that way. That makes my life a little bit easier. Cool. So 0% influence, 100% influence. Okay. Now when we do adjust weights, it looks like I got it backwards in this particular situation, but no worries. Whenever we add a fall off, we get a whole series of fall off options. And if you look carefully, we have a reverse command. Aha. And that's flipping the orientation of the fall off. Excellent. Excellent. And this is all live too, so I can adjust the transition as I go. All the numbers will change. Yeah, it's really cool. It's very cool. Me likey. Me likey. Let's just put it somewhere right around there. That'll do. Say again? It's influencing the application of that tool along that fall off, okay? So at the bottom of the fall off, so down here at this one, the tool is being applied at a value of almost 0%. So we're doing, it's like, so let me show you another example of this, and I think maybe you'll understand it with like something like the move tool, okay? Fall offs are the bee's knees. I love me some fall offs. I use fall offs all the time. Let me turn the fall off. And I'll do this. This is just for Jessica. I want to create a new mesh item here real fast. And it may have. I wouldn't be surprised. Okay. So here is, let's get add a setup. Okay. So, you know, I had a change in heart. I'm going to do this with a cylinder. There we go. Okay. So one of the things that we often run into when we're modeling is globally affecting our entire mesh. Okay. For example, here's my little cylinder. I want this thing to taper as it goes towards the top, right? So I want it to form kind of like a cone or maybe flare out. Okay. Well, how do I do that with all of these edge loops in here? Okay. Maybe my mesh has a lot of detail and I'm restricted to having all of these edge loops in there. So I can't get rid of them, okay? I gotta have them in the mesh, but I need to taper it. Thus enter the role of fall-offs, because fall-offs are a global operator that are going to influence all the active tools based on the type of fall-off that we have. So if I go into my fall-off menu, I'll do a linear fall-off. At the bottom here, the tool is going to be influenced at a value of 0%. At the top, it's going to be 100%. And I'm just going to fire off the scale tool. Now check it out. Because I'm working with the scale tool. Yeah. Now we're getting that taper. Okay? And it's numerically adjusting the value for us as we go across the fall off. And all this is live. So I can change the placement of my fall off and do some fun things. I mean, try modeling that, okay? You wouldn't be able to, okay? The fall-offs are just really, really neat. And if you look at the details of the fall-off menu, you can actually create some really cool shapes, some really neat fall-off shapes. So I use linear and probably radially the most, but there's a number of other different types of fall-offs that do some really neat things. Now, I would really like if you didn't ask me what some of these do, because some of them I have no idea what they do. I'm pretty much a linear, cylinder, and radial guy for the most part. Every once in a while, I'll use noise, which is kind of neat. That makes a kind of a procedural noise texture that can be applied. That's kind of neat. Some of these are new, like soft selection. I don't remember seeing that one in here. In image, I am intrigued by this now. This is a new one. That's kind of rad. You can adjust maybe something by an image. I feel compelled to look at that now. Let me show you some other really great applications of fall-offs. Okay, I'm going to undo here a number of times and get back to my cylinder. Okay, let's pretend that my cylinder needs to have kind of an oval pattern carved into it, right? Or I want to push all of these vertices in here towards the center of my mesh. Well, it's not like I can go in and just kind of grab these vertices, you know, and start moving them. Oops, my fall-off's still on. and move them, right? Because then the results will get horrible really quickly. Well, fall-offs allow us to globally change and adjust which parts of our mesh are going to be influenced. Let me just make a polygonal selection here. Maybe I want all of these guys. Maybe I want all of these guys. And let me, at the very least here, just make it symmetrical so it's easy for our brains to see what's going on. There we go. Maybe this is the section of my mesh that I want to edit. Okay. And within this section, I need it to, there we go. I need it to kind of bow in and create kind of a curve. Well, these fall-offs will help us out in that process. We can do like a radial fall-off and create a circle area of influence. Okay. So at the center of the circle, we'll get a value of 0% influence on the tool. And on the outside of that, we'll get 100% influence. So if I activate like the move tool, for example, I can create something like that pretty quickly. It's kind of like a soft selection to a certain degree. It's pretty rad. Now the cool thing that I like about this is that we can change the shape pretty quickly, especially with linear ones. I'm not so sure you can do it with these. Yeah. Change the shape. I mean, modeling that traditionally would be very hard without a fall-off. Okay. So you can change the shape, ease in, ease out. I mean, model that on a cylinder. And that's on a cylinder. Okay. So that's not arbitrary. That's something that's kind of advanced, to be entirely honest with you. They're cool. So that's what fall-offs are doing. They're allowing us to globally affect a whole series, basically our entire scene or a selection within that scene based on the shape of the fall-off. It's influencing how much or how little that tool is influencing that object. They're amazing. Maybe. I've never tried to do it with a face before, but yeah, potentially, for sure. Okay. Let's go back to my other cylinder that I had rigged, and we'll keep going. All right, let's go back over to the Setup tab. All right. Okie dokie. So let me just reset all of this stuff. Woo. Well, that's kind of fun. Well, maybe it helped if I grabbed everything. There we go. All right, now I believe, if I remember correctly, it was the middle joint here that was influencing the entirety of our scene. Ooh, I did something that I probably should not have done. There we go. Okay. All right. Okay. So let's see what happens here. Reset our rotation. Now when I move this, get a much more natural bend. Much more natural. Okay, we're not getting as many of those hard edges as we were before. It makes sense that we're getting a hard edge there because this row on our cylinder, is the border of that 0% influence. Okay. All right. So that's basically, in essence, what we're doing when we're binding our characters to the skeletons of our mesh. Okay? Or excuse me, I said that backwards. When we're binding our skeletons to our meshes, we're adding these vertex maps that are influencing how much deformation along the geometry that joint is having or is producing. Okay? Are there other things that you can do other than rotation? You could, absolutely. Absolutely. So if I grab the root joint, for example, I could move it if I wanted to. Could move it around. Can scale it. Scaling is not something that I would historically really suggest that you do, but you can. You can do it. Okay. And when I scale all of it simultaneously, you can see that it all gets big, all gets small. So yeah, you can. You can. I think there are some joints that you're going to want to move. Some locators are going to want to move. For most of your skeleton, you're going to be rotating things for the most part. I would shy away from trying to scale things as much as you can. I've seen things get complex, let's put it that way, when you start scaling things. A lot of problems seem to bubble to the surface. All right, questions on my little example here? No, everyone's good. Surprisingly, everyone good. Kind of understanding it a little bit better now, I think. Yeah? Okay. All right, well, let's go back to our green dude here and start looking at how we can apply what we've just learned and those concepts back to an actual character rig for our little green guy here. Now, last week we very quickly went through and we infused a skeletal system. I want to show you a couple things in here about the application of our skeleton that's really important going forward. We always need to be looking precisely at the orientation of our joints as we create them. Okay? Because we want to make sure that along certain hierarchies within our system, the orientation, so the rotation of our joints, are all the same. Let me show you what I'm talking about. I think it's most easily seen along large hierarchies, so the spine and the legs. Okay? Let's just run through real fast and do the spine and the legs on my little green dude. Let's go into setup mode and do this. Okay. So let me go grab setup tool, skeleton, and we'll just start rocking and rolling here. All right. Now, where are all my joints? Ah. This is actually my fault. I opened up the wrong project file. Let me open up the right one. I was fooling around with this earlier today. Here we go. I was fooling around with some stuff and I forgot to remove some elements that are influencing the placement of all of my skeletal joints. Huh? The magnifying glass and their settings. Are these in here? Yeah? Oh, well, I'm sorry. I like my rigging thing down there. Not for me. But if it's in the way for you, Mr. Ty, I will remove it for you. And what this is doing, FYI, just so everyone kind of understands what you're doing, I actually really abhor that little arrow because it takes over your entire interface, okay? What they're doing here is they're maximizing the viewport in the scene, and I don't like discussing it and talking about it because I think it's stupid. I really do hate it. No, I really do. In the previous versions of Modo, what it would do is that it would, if you're like Mod Quad or if you're in the UV window, it used to be so much better because you used to just be able to click the arrow and it would take over just both of the OpenGL windows. Now it's taking over your entire interface, and it has become a useless tool because now I've lost all of my toolbars and my options, and I hate it. I think it's stupid. But that's just me. I'll leave you guys to explore it and use it on your own. I historically have, to be honest with you, have forgotten that it's there. So, yes, sir. Yeah, so make sure in your tool properties, make sure that your symmetry is off. Yeah. That's the other thing that I really wish they would fix. I don't like having all my tools and my tool properties in another tab because it's very easy to forget to change tool properties when they're not glaring right in the front, you know. Okay. Yeah, you can, absolutely. Now, Moto has a pretty fantastic interface. Yeah, you can. Let me undo a couple things. If you really want to do it, you can do it. This little gold dot in the upper left-hand corner of every OpenGL window. If you hold down the command key and drag, hold down the control key and drag to the left or the right, what you're going to do is split that OpenGL window into two. Okay, so you can, absolutely. Now, what I would encourage you guys to really try not to do is single left-click on that gold tab, because single left-clicking on that gold tab is going to bring it out into popover. Well, actually, in this case, with with the toolbars, that's fine. You can absolutely do that. That's not so bad. Let's see. I'm going to dock it back and hold down the control key, left-click and drag to the right. And then, in order to change all this, that's where this arrow comes in. This arrow over here will change you what you're seeing inside that OpenGL viewbar or viewport. So let's do properties, tool properties. And there we go. Absolutely. So now I have my tool properties in two different things. Okay. Let's work with that. That'll do. Looks like my action centers are still on. Whenever you see that little cyan cross right there, that is your automatic action center rearing its ugly head. So I almost always turn that off. Okay, skeleton tool's on. Yeah. I really want to draw a skeleton, guys. I'm joking. I'm totally joking. Yours is all whacked out. So if you want to just completely like nuke it back to the factory defaults, go to the top of the screen where it says Layout and hit Restore. Okay. Now, when you click on that, you're going to get a little popover. And new in 701, they've changed their whole layout kind of paradigm, if you will. And they have, these are the ones that you want to kind of look at. I kind of hang out in the tabbed layout. I'm not sure if I actually showed you guys this. Did I show you guys the layout switcher? Yeah, okay. It's the command tilde or control tilde, whatever it is. I use it so infrequently. So I'm an old school Moto guy, so I hang out in the tabbed one. But you can go to like each tab has its own layout window now. So there's setup, here's topology, here's paint, here's UV edit, or there's UV edit. So lots of options. Okay. Some people really like it. I'm on the fence. I find it takes me, a second longer to get where I'm going with this kind of thing going on. So I just stay in tab and then just click on the one that I want. Okay. Let's go and do our dirty work here. Oops. Wait a minute. Oh. Whoop. Sorry. My little graphics tablet here is wigging out. Oh, that's good to know. I didn't know that render try was still in there. Setup split. That's kind of what I wanted. And I want this to be toolbars, or excuse me, I want it to be, what was it? Properties, tool properties. Okay. So now I can go in and draw my little skeleton. So symmetry's off. Go. Now at times people get a little clumsy. If you're putting these things down and you get a little kind of wonky, that's okay. Don't worry, we can always go back in later and fix all of the problems that we made. So if you get a little sloppy, you mess up, the placement of some of these joints are not where you want them to be after you create them, don't freak out. You can always go back in and change them later, okay? We haven't bound the skeleton to the mesh yet, so we're cool to edit these whenever we want. So let me show you a couple little things here that will help, because clearly this is not, maybe in 30 years when I'm old and gray, this is what my spine is going to look like. But right now, my spine doesn't look like this, okay? It's nice and straight, okay? So I want to make it straight. Now, there are 1,000 different ways to skin this cat. I want to remind you guys of the power of the snapping system, because I think this is a really, really powerful thing that people overlook. We forget often about the awesomeness of snapping, right? Especially when we pair it to the grid snap. We have this lovely grid in the background. Let's use it to help us create and move all these joints where we need them to go. Okay, so check it out. I'm going to go back into my snapping tools, and I want to hit the F11 key, and I'm just going to make sure that my grid snap is on. Okay, now when I start moving these things around, it's going to snap to the grid. Okay, and I'll just kind of walk up the chain here. Now I'm just moving them. Ta-da! I'm getting them where I need to be. Okay. So this is something that you'll want to kind of keep dialed and look at. There we go. As you work with the tools themselves. Okay. If I turn the green dude back on, yeah, now we're good. Turn off snapping, and I might just move a couple of these back down to where I want them to be. This is a good time to start to go in and mess with the location of all of them along the spine. Okay. Now, last week we started talking a little bit about compensation. Does anyone remember what the role of compensation is? What does it do? Let me show you an example here of why we should be aware of what compensation is choosing to do with inside of our hierarchy. If I go down to, let's say, that joint in the middle of my spine and activate the move tool, what happens? Yeah, it moves all of its children. So visually on the screen, it's moving all the joints that are above it vertically, okay, or below it hierarchically, okay, over in the item list. Well, what if I just want to move just that one joint, okay? I don't want to move everything else. I just want to move that one. That one? It's Friday. Things are going to get weird here in a minute. All right. And trust me, it's not going to be like Miley Cyrus weird at the VMAs, so don't worry about that. Okay, like 2 people got that joke. 2 people. I thought it was funny. In my mind, all the little people in my mind were rolling. Okay. I have a lot of little people in my mind. I don't think that's healthy. Yeah, right. Yeah, right. Okay, so what we need to do is just really look at the role of compensation, because compensation is going to allow us to isolate certain items from being controlled by their parent. Okay, so I have the move tool activated, and as you can see in my tool options, check it out. We have child compensate. So if we turn that on, look what happens. Now I'm only influencing that one link in the chain. All of the joints visually that are above it are remaining in their current location, and I'm only influencing the location of that one joint. So that's a good one to keep in mind if we want to isolate the movement of a very specific item within a hierarchy. So I can just go in very quickly, figure out where all these joints need to be. At times you want to have this on, other times you don't want to have it on. Okay? But you just need to be aware that it's an option for us, because I don't want you guys to go crazy here. So it's just in your tool options. Your tool options. It's one of the tool options. Okay. Okay. That's a good start for us for today. Okay, so here's my little guy. Things are looking pretty good, but we're just going to turn off the mesh, and in item mode, just want to make sure, I want to grab the root here, and I want to look at the orientation of all of these joints within the scene itself. Okay, now this is where it kind of gets a little bit important. Okay, at the center of each one of the joints, clearly we get an item center point, and we're getting its standard XYZ orientation kind of disc, right? Those little lines that come out from all 3 axes. Well, let's look very, very carefully at each one of these discs and analyze if they're orientated where they need to be. Okay? Let's look at them real fast. So here's my root joint down there. Okay? Start to go up the spine. Okay. Now, is there a pattern here? Look carefully. Say again? Z-axis is facing up. Absolutely. We like this, okay? We need to ensure that all of the joints in our hierarchy have at least one axis, have at least one axis that's aligned to all the other axes along those items in the chain, okay? In my little skeleton, each joint has the z-axis facing up, okay? And it's uniform except for the top one. The top one is kind of, we don't care so much about the element at the end of that chain. It really doesn't have an influence on anything in our mesh, so it's kind of a throwaway, okay? We don't necessarily care about it. It's all the ones, it's basically starting at the root, down here at the bottom, okay? This is what we need to pay attention to, and then ending up here, okay? So we have some issues in here that we need to resolve, okay? If you look at them from this perspective, yeah, you know, that Z indicator on my joint here probably isn't where I need it to be. It looks like it's extraordinarily off axis. Extraordinarily off axis. So we need to do some alignment here to get this where we need it to go, okay? All right. So we can do this globally if we'd like. I think at times it's good to do it globally. What we don't want to do is go in and on every single one of these and rotate them by hand, right? We don't want to do this because that is just nightmarish. We want to affect these globally as best we can. So let me grab the root joint here, double click. And let's go and start to examine some of our alignment tools, okay? Now, these tools up here, match and align, those are really kind of things, those are tools that we want to use when we're trying to match and align the position or the rotation of one item to another item, okay? We want to kind of align all of the center points and all of the joints, okay, to our global XYZ axis, okay? So the align command down here, the little blue icon, is probably a little bit better for us to work with, okay? All right, let's just do it. We're gonna get a little popover here, and if we look at the popover, it says the mode. Okay, we're gonna change the item's center point, the orientation. Well, we're gonna put all of the x-axes facing up. Okay, and then so the first orientation value that we hear is always going to be the axes that's going to be placed kind of like globally up, if you will. All right, so let's just look at that one first, and then we'll go to what the second one does. The comma, the z-axis. So ignore z-axis for the time being, and I'm just going to hit OK. Before we do it, let's just kind of refresh our memory here. Is the inside of our global scene, which direction is the x-axis for that joint? Which way is the x-axis facing? Yeah, negative z. So just remember that. And almost all of the joints, not all of them, but almost all of them. Some of them are facing positive z, but they're all facing down the z-axis. So when I do a line, x and the orientation, the x direction, boom, watch what happens. That's pretty cool. Now all of the x-axis, the item center points has been rotated, so their local orientation is kind of pointing down the bone. Okay, they're no longer facing the global orientation of our XYZ axes. They're looking at the local orientation of the bone, okay, of the joint. Let me hit undo for a second, and we'll zoom in and take a look at them. Okay, check that one out. See that one right there? Look at which direction the positive z indicator is facing. Okay, it's facing kind of up, visually up, which is positive y within our global scene. When I do the alignment command, so this one, watch what happens. Boom. Its x-axis indicator is pointing down the joint. Okay, it's pointing at the bone. That's the next one. That it's pointing at its child. Excuse me. Okay. This is great. This is really great. This allows us to very, very quickly go in and adjust a whole number of joints at the exact same time and kind of get all their orientation values dialed in. Now, we really only care about two of the three axes on each each joint. We don't care so much about that third one, because if we got 2 out of the 3, the third one's already pointing in the direction that we want it to. And ultimately, we will only really care about, especially with arms and legs, we only really care about rotating these joints along one axis anyways, okay? Like for the leg, you're only going to be rotating your arms, okay? You're only ever going to be rotating your elbow one direction along one axis, right? You're not going to be twisting it, okay? Well, if you were to twist it, you'd do it through something that's called a pole vector, which we'll talk about momentarily, all right? So we want to make sure all the local orientation of the joints are pointing down the chain, if you will, or up the spine like I have here. All right. So that's pretty cool. Let me hit undo. There are some other options in here that we can look at. So we can do maybe Y direction. So all the Y orientations are going to be blasting down the joints. That's kind of a popular one. I see that one being used a lot. That's kind of cool. So let me hit undo. We can also do maybe Y direction, X axis. See what we get there. And now we're kind of more globally reaching kind of the orientation that we're after, okay? If you look at this one right here, it's local orientation. It's kind of similar to what we're used to seeing inside of our global orientation, okay? The big picture idea here is that you need to have all of your joints with one axis pointing down all the bones, okay? That way when you rotate them, you're not going to get any sort of weird twists and, you know, kind of funky things happening. Before you bind. You want to have all the skeleton just completely dialed before you bind.
It really doesn't matter if that's just as long as, like, for instance, how right there it's the Y-axis pretty much pointing down the bone.
Yeah.
As long as it's pointing down the bone.
As long as it's pointing down the, you know, for today, you know, for starters, just pointing down the bone. Okay? Just get one axis that all the joints are aligned to going down the bone, and we're on our way. Now, why is this important? Let me show you why this is important. Yeah.
I was going to say, we saw a little bit of this in Henry's class when we had a little robot thing.
Yeah.
And then we were adjusting weight value or the limit values, like for toe movement or foot movement, greater than 90 or less than 90.
Uh-huh.
Something like that. We put limits on there, but it was already set 0 when we first looked at it. And I guess as the animators, you're not supposed to touch that stuff.
Yeah.
And so it was supposed to be preset so that the limits look natural and they wouldn't work and then rip away the meshes.
Yeah. That's a joint orientation problem. Yeah. So here's why it's kind of important. And FYI, when you're done with this, you definitely want to zero out everything. Okay. That way, each one of your joints thinks that its current configuration is its bind pose. Okay. Now, so why this is important is that when we start looking at our tools here, you can see that as I go up the chain, my spine can be completely adjusted by the same axis, and that's what's important. We don't want to be able, you know, if you don't do this, in order to get the person to bend over on this joint, you'll be rotating the x-axis, and then you go up another one, and now you're rotating the z-axis to get it to bend, you know, across the spine. We want the spine to bend and rotate all along the same axis. Okay. Kind of makes sense a little bit. No, I don't. So if you're trying to bend, like, so let me just take a step back here, Austin, so I'm on the same page with you. So here's my character, right? So this is the head. So if I were to rotate him forward this way, it should all be positive values, right? So positive, yeah. So this is what you should be getting. Are you not getting that on yours? The other direction. This is probably why that did you already do the alignment? Yeah, you already did the alignment. Okay. So, well, if the other thing that you might want to, the other thing that you may want to look at as you go through this process is the actual is the actual orientation of all the axes. Okay. Now, if you look closely at mine, on this one, positive x is facing to the right. On that one, positive x is facing to the right, and now it's facing an odd direction. Okay, it's not necessarily facing the right on that one. You can go in and individually edit the location of the center points and rotate them where you want them to go. So if I grab my center here, activate item transform, and I'm just going to go to the local orientation, and I'm just going to spin it 180 degrees. There we go. Drop it, and then zero out rotation. Now, when I click on item mode, come on, fingers. Yeah, now everything is aligned to where I need it to be. Okay, so you can do it by hand. I think the alignment tools here are a good way just to get us started. Sometimes you have to go in and tweak things. Okay, but local orientation. Okay, and only edit them at values of 90 and 180. So you stay aligned with the entire thing. Okay? Questions so far? Yeah, Kaylee and then Katie.
What happens that you didn't align your points? Like, what happens if you didn't align your points and you already like merged your model with your skeleton and you didn't do the points before?
You're gonna rip a hole in the space-time continuum. Okay, the sky will turn green, the grass will turn blue. You know, cats will chase dogs. Okay.
I take it that's a bad thing.
You know, it's not the end of the world. It's not the end of the world. Is your rig gonna work? Absolutely. Are you gonna be able to animate it? Absolutely. Are you gonna run into problems? Absolutely. Okay. It's just going to be a little bit more difficult to wrangle your rig and to get the character moving the way it needs to move.
Okay.
So it's something that we want to try to do. If we don't do it, things I'm going to show you after the break might influence your rig negatively. Let's put it that way.
Okay.
Okay? All right. Questions? Yes, Katie, I'm sorry. For this one, it doesn't matter so much if you're in setup mode. Yeah, I've been out of setup mode for the last 10 or 15 minutes. So setup mode, you have to be in setup mode when you're doing the bind operation. Got to be in setup mode for that. You also, it's better to be in setup mode when you're doing all your paint weightings, your vertex map weighting. The performance is better, and I think it's a little bit easier to see exactly what you're doing. And anytime you need to make a change to the original bind pose, so anytime you make a change to the character, you need to be in setup mode after that. My kind of golden rule is try to be in setup mode whenever you're editing the rig, okay, and all the rigging components, okay. Questions? Everyone good? Yeah, Chevy. Yeah, you know, you want it to be local to the bone, to the joint itself. Yeah. Yeah, you could do it to the global orientation of all the axes. That's not a bad thing. You may get some really weird transformations when you start moving all those joints. So I like to keep it local as much as I can. You got it. I like it. All the pointy things. Yeah, just have the pointy things point down the chain of bones. Okay. All right, questions? Let's take a break. A little 5-minute break. It's an awesome character, Katie. I love it. It's like gigantic, like space monster. It's a space worm.
Oh, yeah.
It's a space worm.
I discovered that
Yeah. And maybe when I say 5 minutes, I mean 10 minutes. Okay, so before the break, we were just talking about some very simple transformations that we can do to our spine just to get all the local orientations of the joints where they need to be. Okay, I want to spend some time talking about the legs, and pretty much the rest of the day today is going to be talking about the legs, because as we saw from last week's exploration, if you will, into the rigging process, controlling the legs was stupid. Right? It was just really difficult in order to, to get good transformations along the legs. Let me show you what I'm talking about. Last week when we were working with this is what we had, and I just wanted to kind of rebuild it real quick, just so we have a point of comparison. And let me just name some things here. Root, and then this, I'm going to call this spine 1. There we go. All right. Let's turn my green dude back on and reactivate the skeleton tool. And this time, I want to turn symmetry on the X. We'll just start going in and placing these joints for the legs themselves. Okay. Now, for the legs, we've got to be very careful where we place some of these joints, because we're gonna expand upon this rig here momentarily to get some more controls on very specific areas. So I want to place one joint down here kind of where the ball of the foot would be, and then another one out here where the toe of your foot would be. Okay, somewhere right around in there. It's not science, but somewhere like that. Okay, because ultimately what we're trying to achieve and generate here is the ability for our little foot to do this. Okay, that's the goal. We want to be able to do that, and by the end of today's discussion, we will have done that. Okay, so let's just take a look-see here at what we got going on. Yep, I'm pretty happy with that. Now, before I drop the tool, look at all the local orientations of the axes. Right now, the z-axis is blasting down each one of our bones, and that's cool. I like that. I like that. That way, I can just rotate the y-axis on all of these guys, and we'll be on our way. Case in point, let's just go into item mode here real fast, and if I grab like this middle one, rotate the y-axis, and we're good. On the ankle, rotate just the that one. It's pointing the right way, but it's saying X, but that's okay. Sometimes they're flipped, and that's fine. As long as the z-axis is flowing down all of them, I'm happy. I really am. All right. That looks pretty good. One other thing that I want to remind people of, you can absolutely add more skeletal hierarchies as you go. Here's the spine that I was just creating, but now I have 2 new hierarchies. These are each one of the legs. So you can do this and have all these hierarchies disconnected and then reparent them to the spine or to the root when you're done. Okay? That's totally cool. It's an easy way of working through this process, okay? Because if you think about it, the spine is one chain, each leg is a chain, each arm is a chain. We just need to take all of those chains and link them and parent them to the correct location at the end of the process. All right. Say again? How do we parent some? How did you parent the chain? The chain links together. Just drag and drop. Yeah, that's all you have to do. So if I wanted to parent both of my legs to the root, just drag it on top of the root, now I'm good to go. So now I have the spine and then both legs. Shoot, while we're here, let's just name them real fast. Call this, I don't know. My properties panel is saying mixed. Oh, I got them all selected. There we go. Yeah, let's just do leg R. Okay. And this will be leg L. And let's get a little bit more specific on this, because I think this specificity is going to help you understand all the different parts and pieces that we're going to be generating here in a minute. So instead of doing leg, let's do leg, or we'll do left thigh. There we go. Great power user keyboard shortcut. If you're like me and hate hitting a bazillion of these little arrows to get down to the bottommost element within your hierarchy, here's the power user shortcut you've been wishing I had told you for a long time. Hold down the shift key, left click on it, boom, expands the entire hierarchy. Boo! I know. I'm sorry. I'm sorry. You gotta feel the burn before I make it easy. Okay. This is where people start like burning me in effigy, and they start protesting the picks and the torches. Sorry. All right, so let's examine our hierarchy here real fast and see what we got. We got the left thigh. That's that one. Then we got what I'm going to call the left calf. Okay. Then we have the left ankle. Left ball, or yeah, and then left toe. Okay, so we have thigh, calf, ankle, ball of the foot, and the toe of the foot. Those are the major joints for each one of our legs. I'm only going to focus on the left leg. The right leg is identical, and if you do this carefully, you can actually duplicate this hierarchy pretty quickly. So I'm all about having to do things once. Okay. So up until now, last week when we were working with our legs, there was only a certain degree of control that we were able to create. Okay. For example, the control that we had purely was just a rotation. But what if I wanted to make my guy squat? What if I wanted to have him bend over and pick something up? In its current configuration, doing that would require just a tremendous amount of work, right? We'd have to rotate a bazillion little joints to get us where we need to go. For example, what we would have to do is something maybe kind of like this. And bend the knees, bend this kind of up, and then the ball of the foot kind of up. Oops. The ball of the foot kind of up. And then this one, you rotate up. And then you'd have to grab like the entire root and move it down. I mean, it's just a tremendous process to do something extraordinarily simple just to make my guy pick something up off the ground, right? Well, there's some extra stuff in here that will allow us to very, very quickly go through and enhance our rig to include some elements that will make things like this easier. And we're going to apply what's called an IK goal to our chain and IK handles to allow us to do something kind of like this, right? This is the goal, to have my guy standing at the T-pose, right? And I want to be able to do this. Not the jump. Just that, okay? That's the goal. That's what we're trying to do here, okay? In order to do this, we got to add some IK handles. And the process of adding IK handles is really, really easy. However, the first thing that I want to do is I just want to go and zero out everything on this my little leg here. I like to zero things out. Once I got their positions kind of dialed, I zero them out. Then I just double check to make sure that they are in fact zeroed out. And now we can start rocking and rolling. Okay. Okay. Adding IK handles into the mix is not difficult. Okay. It's really easy, but we have to be very mindful of what we select. Okay. Since we're adding some new elements into the rig, naming each one of these elements is going to be a critical factor, okay? We're going to be logarithmically adding elements into this control rig over the course of today and next week, so it's important that we stay on top of our naming conventions. The clearer we are with the name of our locators and all these IK handles, the more easily it will be for you guys to work with these rigs and edit them and animate them, all right? In order to add an IK handle, we first have to select the thigh bone, that top joint in the hierarchy. And then we're going to hold down the Shift key in the OpenGL viewport and click on the ankle down here. Boom. Those two. All right. Pretty cool. Hold down Shift. Yep. So we're grabbing the thigh and the ankle bones. Once those two are added, we can go over into the inverse kinematic tab inside of our setup tools on the left-hand side there. The inverse kinematic tab is going to gain us entry. Oh, I need to be in setup mode, by the way, which I am not. There we go. Which is why my assign IK was grayed out. Got to be in setup mode for this. Assign IK. Now, on the surface, it looks like nothing's happened, okay? But something has happened. But more importantly, look at what is still selected, okay? The thigh bone has turned off its selection, and down here at the base, we have that ankle bone selected. So before you click on anything else, immediately go over back to your toolbar and do assign IK goal or add goal. That one right there, okay? And you're going to get a green little box or a colored box on your body. Let's go through that process one more time so everyone's on the same page, okay? The first thing that we're going to do is select the thigh bone. Okay, grab your thigh bone. Whoa, awesome. Hold down the shift key, grab your ankle bone, okay? Ensure that you're in the setup mode and travel over to the inverse kinematics tab. Once you're there, choose assign IK, and then immediately after, hit add goal. So what's happened here? Let's get out of setup mode and start to examine all the pieces that we just added into the scene. Whenever we assign an IK handle and an IK goal to the scene, we're basically creating a really cool relationship between a whole series of joints. Specifically, the joints that we're now influencing are the thigh, the knee, and, well, not really the ankle, but it's terminating at the ankle. If we examine our hierarchy here for a second, check it out. Here's our left thigh. That's the one that we had selected. And if we keep cruising down that hierarchy, you can see that a new element has been thrown into the mix. It's the full body IK. If we follow its dotted line, it's actually parented to the left thigh. This is absolutely before binding, okay? In every sense, you're going to be redoing this rig again, okay, with these new elements this week. So full body IK. If we click on that full body IK locator in the scene, you'll actually get a nice cool, there it is, it's up here at the top. So if you're getting this kind of mess, if you see two circles inside of what I would call your hip, then you're doing okay. That's exactly what we want. And of course the goal down here at the bottom is really where all the magic's at, okay? The goal, if we were to move the goal, check it out. Let's just do the world orientation here. Yeah, now we're influencing a number of joints across our character. Okay. Okay. It's pretty cool. But there's some problems in the mix here, is there not? The knee is going crazy, right? The knee is going crazy. Whoa. Whoa, look at that. Yeah. Okay, so we got some problems in here that we need to fix. So that's how easy it is to add the IK handle, but it's like you kind of take one step forward and a couple steps backwards to a certain degree. We have to go in and fix some of the problems that the IK handle has now infused into our rig. We need to generate a control surface for the knee, okay? Because really we want the kneecap to be looking at a very specific point in the scene, okay? It's called an up vector, and they're really easy to create, but it involves making a couple locators first, okay? So when you're ready to make the knee up vector, or the control surface for the knee, here's what we're going to do, okay? We're going to add a new locator into the scene. There it is. New locator. And we need this locator to be positioned precisely at the center of our thigh bone, so at the top of our hip, okay? Is there a way that we could easily do this? We could do the work plane, but there's something else that's pretty magical inside of Modo that will help us match and align things quickly, okay? Nope, we're going to do something even better than that, okay? Modo has, this is another one of those Modo-specific things that's really, really cool. It's called a drop action. And these drop actions allow us to basically enact a number of different rules and ideas quickly, okay? So there's my little locator. At the top of the screen here, check it out. Here's the drop action pull-down menu. It's this one. These are all the different elements that we get to perform when we drag and drop certain items on top of other items within the scene. And what we want to do is match position, okay? So I want to change my drop action to match position. Check this out. Once you start working with these drop actions, you're never, ever, ever going to want to go back. So match position. And check it out, okay? I'm going to grab my locator, left click and drag, and see that the name of that item is underneath my cursor. And I'm going to drag it on top of my thigh bone. Boom. And it figured out where its center point was, and it matched the position of my new locator to that center point. Automatically for us, and it's rad. I love it. It's very, very cool. It didn't change its local or world orientation, so everything is still positioned where it still needs to be. Rock and roll. Things are good. Okay, things are really good. What we're going to do with this locator at the top of our leg here is create a new root position for our leg. Question, Alex.
This right here is why Moto is way better than mine.
The rigging tools are redonkulous. They really are. They are the best in class, in my opinion. They are incredibly strong. Once you really understand the rigging process, the tools make this whole process go a whole lot faster. Okay. Towards the end of the semester, and I'm gonna give you a little foreshadowing of my big crazy idea here. At the end of the semester, I'm going to show you some other rigging things just to kind of tease your interest a little bit. There's this thing in Moto called weight containers that are awesome. Absolutely. They're used all over the place. And weight containers are the coolest thing since sliced bread, especially the Moto implementation of weight containers. They're great. They're really, really great. But we're not quite ready for them yet, so we'll get to it later on in the semester. Okay, so what we're going to do with this locator up at the top of our leg is basically use it as a new root, if you will, for our entire leg hierarchy. So let's name it root, okay? Let's just give this guy, we'll say, let's do left leg root, okay? Left leg root. All right. We'll just leave it outside of the hierarchy for now. We're going to need another locator, so let's go ahead and pull it out. There it is. Added a new locator by clicking on that little button in the scene. And now we need to match the position of our knee. So once again, I'm going to utilize that drop action. You can see that up in the menu, match position is still enabled, so I'm just going to drag and drop it on top of my knee bone. It automatically moves to where it needs to be. Now, I don't want the control surface, the up vector for my knee, to be just chilling in the center of my kneecap. I need it to be offset a little bit. So I'm going to just move it forward along the z-axis to get it in front of our knee. Say again? Are these going to be the controller buttons? Yeah, this is going to be a control surface for the knee at the end of the day. Absolutely. Okay. And since we're here, let's just call this knee control. There we go. All right. That's a good placement for it. In addition, since we've moved it, let's zero it out. There we go. And we're on our way. Okay, now we need to start assigning the up, or creating the up vector that will control the rotation and the placement of the kneecap along our chain. And it's really easy to do this, but ultimately we're going to use that root, that locator that we put kind of in the hip. We need that guy to be looking precisely at our ankle, and specifically that IK goal at the bottom. Because right now, if you look carefully, this one up here, it's orientated to the global orientation of our axes. We need it to be looking, boom, down here at our IK goal. Okay, so I'm going to hold down the Shift key and click on it like that, and I'm simply going to do a directional constraint. Boom. And that's what we want. So now it's always looking at that IK goal. This is ensuring that basically our ankle and our hip don't go too far away from each other. Okay? So that's step one. Question, Katie?
I was just wondering what you just did.
So I grabbed that top locator, the new root locator that I created, and then I held down the Shift key, and I grabbed the IK goal, that green cube at the bottom of my leg, and then I applied a directional constraint. Shoot, while we're at it, let's just name the IK goal. It's important that, let's call this left leg IK goal. There we go. Just so everything is nice and cleanly named. Okay. Now we have to go through and assign the up vector, and it's really, really easy to assign an up vector. But there's a couple things that we have to go select. Okay. Whenever we're assigning the up vector, or excuse me, let me take a step back. We assign up vectors when there's a directional constraint in the mix. Okay. Because Because a directional constraint is always going to be looking at something else within our scene, right? Well, we want to kind of pin one of the axes within that directional constraint to look at something else in the scene, okay? That's called an up vector. Most of the time, up vectors are assigned automatically by the computer, but we can override that to ensure that one of our axes along our directional constraint is always going to look at our knee, okay? Or that locator in front of the knee. So it's really.
Which two items did you select for your directional constraint?
I'm sorry. Can you say that again?
Which two items did you select for your directional?
So for the directional constraint, I grabbed the locator that I placed at the hip, right? And then I shift-clicked the IK goal, that cube at the ankle there, and applied the directional constraint.
Because I remember, like, that, one of your other videos, the week before last, said what goes first.
Yeah. In my mind, the one that you select first is the item that you want. Let me rephrase it. What you select first is going to look at the element that you select second. Okay. I want the hip to be looking at the IK goal. Okay. All right, so I got to assign the up vector here, and the first thing we got to do is we have to go find that directional constraint, and there it is. There's the directional constraint. It's under left leg root. So if I click on the directional constraint, then hold down the shift key and grab that knee locator, over in our modifiers tab, this assign up vector button becomes ungrayed. Okay? You really can only apply up vectors when there's a directional constraint within the selection process. Okay? So I'll assign the up vector. Boom. And there we go. Okay. Now on the surface it doesn't look like much has changed, but check it out. Let me go grab that guy there. And things are working, okay? And it's actually working the way we want it to work, because if you look very carefully, that locator at the top of the hip is rotating, which is what we want, okay? Because now we're kind of overriding a portion of that directional constraint. But what isn't moving? The leg and the knee. So we have some parenting in front of us to finish this job up. All right. Basically, if you look at our hierarchy over here, okay, the one that I have selected, this is the original skeletal chain that I created at the beginning of the day, okay? It includes the original left thigh, the original left calf, ankle, ball of the foot, and toe, okay? This is the original. Well, all of this, the left leg root, this is the new stuff that we've been generating. All of this new stuff has the IK goal stuff parented to it. It's got that new up vector. So we basically need to combine the old chain with the new stuff. We're simply just going to parent it to each other. It's going to be really easy. And this kind of illustrates why I named the new stuff left leg root, okay? Because this is in many ways going to represent the new root structure for my leg. So I'm just going to grab my old left leg, drag and drop it on top of left leg root. There we go. Now, if I grab my little pole vector here, yeah. That's what we're after. Because now I can grab my IK goal, move it up, and then grab my knee and move it where it needs to go. Okay? Yes, sir. Okay. So assign up vector isn't up. Let's take a look at it.
It's not coming up purple.
All right. So you got to click shift click on the knee. Is that the knee one right there?
Yeah, it's the new one. I think everything's really
There we go.
Oh, okay.
There it is. Now, one of the things that I can see on Austin's screen that I can see in others is that your locators are ginormous, okay? You can scale them down to make it a little bit more manageable to see inside your OpenGL viewport. If this is what you're running into, check it out. You can grab any locator and then go over to its display properties over here, and this size value will determine how big or small it is in the scene itself. while we're here, let's just make it a little bit more easy for us to consume all of this information. I don't want my knee, my up vector for my knee to be the standard locator cross. I want it to be something else because I want it to be really obvious that this is a control surface that our animators need to interface with. So let's just do it real fast. It'll be pretty easy. I love adding custom shapes into locators. It's a lot of fun. So I'm in the knee control locator, the display tab. And let's do this. Let's do some add draw options. And let's also change the locator shape. We don't want the shape to be the default, which is the cross. We want a custom shape. And let's figure out what we want here. We want to replace the locator, the original locator shape with the box. There we go. We don't want a box. Let's do like a pyramid. Yeah, a pyramid would be kind of cool. Or, yeah, a pyramid. I think I like a pyramid. The reason I'm going for a pyramid is because we get a point. Okay, it's a good way to remind our animators which orientation this locator needs to have. It's a little gigantic, so let's make it small. Yes? These are the defaults that come with Modo. But if you wanted to do your own custom shapes, I guess you could just parent them to the locator, and you're ready to go. Yeah, you could. Yeah, absolutely. That's fine. That's fine. Yeah. So what Jessica's asking is, can I make like a mesh item that contains just an R? Yeah, you can do that, and then just parent it to the locator that we're working with right now. I would, you can do that. That's fine. I think some people, in my mind, that's kind of an old school way of working, but if it makes sense for you, I say do it. Animation inside of any computer application is already pretty difficult, so I'm all about making it easier. I would encourage you to look at this method because this method gives us the option to colorize a number of these elements pretty quickly. And I think from my own personal experience, people respond better to color than they do labels. That's just me. Okay, so let's actually talk about color. I've made it pretty small. That's looking pretty good. I like that. If you go back to the 3D items thing, this is where the draw options really come in. Let's see. I want it to be a user-defined color, and the fill color for me is going to be a lovely shade of green. And then the wireframe is also going to be a user-defined wireframe color, and I'll make it I don't know, maybe a darker shade of green. There we go. And if you click off of it, you can see what it looks like. Okay. I think color coding locators, especially control surfaces, is a really, really, really good idea. Ultimately, we can remind our animator of the symmetrical items within the scene. For example, all the control surfaces on the left side of the rig will be green. All the control surfaces on the right side of the rig will be blue. And all the control surfaces for the head and the spine can be yellow. Okay. That way, we're visually separating out all these pieces so that it's easy and quick to find what we need and rotate it and move on our way. Yeah.
So my knee's still going black belt when I lift this up.
All right. Can you move your knee locator? Yeah, okay. So we need to parent all of these guys. Okay. To you've already done it. Okay. No, you've already done it. Now, did you do the directional constraint?
Yes.
Yeah, okay. Maybe your knee locator's too far away. Bring it in, yeah. Now when you bring up your IK handle, what happens? Now grab your knee locator and move it. Move it left and right along the x-axis. Yeah, it's working. It's working. It's only gonna the knee locator is really gonna influence the rotation of the leg left and right along the x-axis. That's its sole function. It's the only thing it's going to do. All right, questions so far? Everyone kind of understanding it? All right. At this point, let's just zero out. Yep, my knee locator is zeroed out. Oh, one other thing that is worth mentioning inside that display tab. Whenever you work with a custom shape on a locator, check it out. You can still see the center point for that locator. And oftentimes that can be confusing. It's a little bit of visual noise for me. I just want, these control surfaces are really interface elements for our animators. They're not going to want to see the center point often, okay? That's something we can turn off. So if we go into display, check it out. Visible, yeah, obviously, but center point, default is to yes. We can put that to no. And now I can grab it and move it around. We're on our way. All right. Excuse me. One other thing about locators that really makes them a really strong addition to our rigging system is that we can enact and enable certain tools when we click on them. We're only ever going to be moving this up vector, this knee control surface. We're not going to be rotating it. We're not going to be scaling it. So let's automatically have the move tool kind of come on when we click on it. Does anyone remember how to do this? So let's select it first. Yep. Lists. You sure? It's hidden. Assembly. Yeah, you got it. It's under assembly. And then the area that we're going is utility, right? Because we have this field here allows us to enter in a command, a modal command, and this could be any command that we wanted to be honest with you. I mean, we really could put in, like render.scene if we wanted to. We could, if we clicked on that locator, it would just fire off a render if we truly wanted. I don't do that, okay? However, there are some presets that are kind of like highlights, all stars, if you will. If you click on the little drop-down arrow, there we go. Let's do, here we go, the move tool. Awesome. Now when I click on it, the move tool just automatically comes on. Okay. I like that. That makes my life really, really easy. Because now I can just go grab it, boom, on our way. On our way. However, it looks as though we have a little bit of an issue here. If I was to really move this guy up and down, I'd probably want this guy in here to move along with the rig itself. Okay. Let me move these things back. Get that back to its original starting location. Let's just reset all. Whoops. Let's not reset all. Let's just reset the rotation or position. What is going on here? Okay, there we go. The IK handle doesn't get reset, by the way. But we need to parent this knee locator into the mix. Now, which of these elements do you think is a good candidate to parent the knee locator into? Left leg root, I think that's a good one. Left leg root, parent it into the mix. That way, there's a dependency here, so let's not do it. Let's just parent it to the root of our machine, and that totally messed it up. So let's not do that quite yet. Maybe we'll just leave it in there. Maybe we'll do a position constraint to it later so it follows it. It's not necessary, but it just adds a little control. That way it's just not floating out into the scene. All right, rock and roll. Things are starting to look pretty decent. I'm happy with the results that we have, and we're gaining a little bit more functionality in our rig. Okay, so let's talk about the foot, because we want to make some elements for our foot that gives us some control over our foot. And ultimately, what we're doing here is that we're not going to be adding any new joints or bones or anything like that into the foot. We need to add a whole series of locators that will allow us to control the foot a little bit more intelligently. And that's really what this is all about. We just want to control the foot, not influence its behavior. So the first thing that we're going to do is add a couple locators. Okay. Now the first one I'm going to add, boom, there's our locator. The first one that I'm going to add, I'm just going to call this one left foot control. And I can see that my drop action is still set to match position. And I'm just going to drag and drop it on top of the heel bone. So it's just sitting right there. And this left foot is truly, this locator is truly just going to be a control surface for the entire foot. Okay? And ultimately, we're going to parent it to the IK handle. So that's going to come later, but just to kind of give you an idea of where we're going here. All right. So let's get its display settings all kind of dialed here. I want my locator shape to not be a cross, so I'm going to make a custom shape. And I think I want it to replace it. The style, however, is going to be a plane, okay? And let's change the axes of the plane to like Y. There we go. We're going to create kind of like a little footprint for my little shoe here, okay, for my foot. If you look at the display properties, one of the display properties we get is the ability to fill in our little locator. Well, I want it to just be a simple outline. And you can see there it is. All right. And we can also adjust maybe its size a little bit. There we go, something like that. I'm going to basically make it bigger than the actual geometry for my foot. So we turn the visibility of my green dude back on. We have a little bit of an issue, do we not? Okay. This is where these offset values come in. I want to grab the offset Y. Why? Because I can. That's a bad joke. Yeah, boom. Come on, fingers. There we go. And I'm just going to dial in the offset values here until I'm happy with it. That may be a little too ginormo for me. Something roughly like that. I'm going to squish it a little bit on the x-axis. And the only reason I'm making it a little bit narrower is that I don't want this control surface to kind of bleed over our x-axis. It'd be much more difficult to select it if it's sitting and sharing the same space as the control surface for the other foot. All right, there we go. That way I can just go in, I can select it, and I'm on my way. Okay? Well, it's not the root. This is going to be the control surface for the foot. Okay? Ultimately, what we're going to be doing with this is that we're going to be parenting it to the IK handle. Okay? Or excuse me, the IK handle is going to get parented to this. Okay, check it out. I'm going to parent it, boom, just like that. That way, when I select my foot, hit the Y key for item transform, I'm off to the races. Okay? Pretty cool. Okay. This makes it easy for me to control. The reason why we did the offset, okay, in the actual locator itself is that we want the visible square to be at the bottom of the foot, but it's absolutely crucial that the locator be at the ankle in the same place as the IK handle for the orientation and the rotation of the ankle to happen correctly. Okay. That part looking pretty good.
You have two locators there?
Huh?
You have two locators? Or is that the square? Is just
The squares is the IK goal. Okay? The IK goal. All right. So now we need to create a whole series of locators for the bottom of the foot. Okay, we're going to get a bunch of these, so let's just go ahead and make them real fast. We need one for the ankle, we need one for the heel, or excuse me, we need one for the ball of the foot and the toe of the foot. So let's go ahead and just do it real fast. Let's create a couple locators. Let's name this one heel. And the heel is going to be almost, kind of in the same place as our foot control. More on that in a second. I'm going to move it back in space a little bit over here, just so it's easier for us to select. More on that in a minute. Let's create another locator. This one's going to be the ball of the foot. Okay. And again, I'm going to drag and drop that one right there. Okay, I love these drop actions because you can just kind of say, I want you to be in the same place as that one right there. Okay, rock and roll. Let's create another one. This is going to be the toe locator. And I want to drag and drop in that one right over there. Okay. Perfect. Perfect. This is what we want. This is what we want. Okay. Now that we have all of these inserted into the scene, what we need to do is that we need to parent them together so that we can very, very quickly start to work with these locators on our rig. So, in addition to being able to match positions for our drop actions, we can also do parenting, okay? And I like this. This is kind of cool. We get a lot of really neat commands in here. So we're going to do parent, okay? Parent in place is going to do something slightly different. So we're going to do parent. So just by dragging and dropping items on top of each other in the OpenGL viewport, we can create those relationships, which is pretty neat. So let's do parent. And I'm going to parent the toe. You'll see the heel is out over here. There we go. And you know what? I've had a change of heart, and I got to apologize for that. What I think after looking at this, let's just do match position. I want to put that locator back in here. I want the heel to be more kind of down in here. Kind of where the heel is. Yeah, I think that's going to be better. There we go. Okay, so the toe, let's change our drop action to parent. The toe is going to be parented to the heel. Boom. Okay, oops, I guess we need to, excuse me. Let's nuke out all the transformations for all of our locators that we just added. Forgot to do that. 0, all, there it is. Now when we parent, and maybe I should have chosen, I need to choose parent in place, not parent. That's why. There it is. Huzzah. Okay, the toe gets parented to the heel. The ball of the foot is going to get parented to the toe. Rock and roll. So if you look at our hierarchy at the moment, this is what it looks like. Heel toe ball. And then finally, we're going to add in one final locator that's going to be up over here by the ankle. Let's call this one ankle. Let's change our drop action back to match position. I'm going to match it to the ankle bone. And then this entire structure, the heel, is going to be parented to the ankle. No, excuse me, I'm sorry. The ankle is going to be parented to the ball of the foot. Yep. So if you kind of look at what we have here, we get the ankle, then it goes the ball of the foot, the toe of the foot, then it goes back to the heel. That's kind of what we want. All right. So if we just kind of test the system, yep, grab the heel, or we can do this on left control. Go, grab this one. It's going to rotate that way. Good. The ball of the foot. Rotate that way. Okay, good. That's kind of what we want. All right. But none of this is actually connected to the bones yet, so if you've messed up, don't worry about it. These are just locators. That's all we've crafted here are just locators. Okay? Okay. Let's zero out all these locators. There we go. Reset all their transformations to their new position. And now we can start doing something with them, because this is really where the power of all these locators down here at the bottom come into play. Okay? What we want to do is that we want to select the ball joint, which is this guy in here. Boom. There's our ball joint. And, or excuse me, we want to actually select the actual joint itself. Okay? Not the locator. I misspoke. Excuse me. And we're going to hold down the shift key and grab the new locator and do a positional constraint to it. That way, whenever we move, or whenever that locator moves, for example, its joint is also going to move. Okay? And since the heel is the parent of this entire relationship, you can see that now we're actually influencing some of the joints. Okay? And the toe, yep, the toe is almost there. What we need to do with the toe is do a directional constraint. Okay? So we want the toe joint, okay? Oops. So that one right there to be looking at that locator right there. Let's do a directional constraint. That way, everything will always point the way we need it to point. So when I move that end locator down, yep, it's always going to point at it. That's what we want. So that one's always going to be pointing at the toe. Cool. Yep. Cool. And then this entire hierarchy, since it's going to be the left control here, let me just test something here. Apologize. Yep. Okay. This new entire hierarchy and all of its parts and pieces are ultimately going to get parented up over here into our left control, because we want our left control surface to really influence everything. So let's just parent it in there. Bam. Excellent. Let's see what we get. Grab it, fire off the move tool. All that works. Cool. We can even rotate out our ankle a little bit if we want, which is pretty cool. But we can also go in and start to influence other parts of our. Yep. Oop. Looks like I may have a mistake here. Yep, that's where I'm after. Rotate the toe, everything works in. Pretty cool. These are all elements that you'd absolutely want to make sure you have dialed in before. Yeah, excuse me. And I made a mistake. I forgot to reset a transformation along my my left foot control. And since it's parented to a number of other elements in the mix now, let's see. There we go. The one thing, and I even find myself stumbling upon this from time to time, is forgetting to zero things out. You know, whenever you add in a new locator and you're parenting it to it, just zero it out to ensure that its transforms aren't going to influence anything else. Okay, that it's got a new home. New home. Yeah. Heel. Yeah. There's the hierarchy. Yes?
Is there a way to do this symmetrically so you rotate on each side?
Let's find out. Let's find out. You can't do it symmetrically at the same time. But I saw something earlier today that has me intrigued. So if you look at what we have accomplished here, we have the foot section, we have a leg section. Now obviously our leg and our feet probably need to go with each other. So let's go into that hierarchy real fast. And I'm going to grab my left foot control and just parent it to my little modifier dependency loop. What? There should not have been a modifier dependency loop. These are actually all control surfaces. So they don't necessarily have to be parented to the left leg root, but they do need to be parented to the root of the entire system. And something just whacked out on mine. I might have messed up on something in here. I don't think so. Mr. Wilson. Left leg root is just all the leg stuff, but I'm trying to get, I need to get all my left foot stuff parented into the mix, and I think I've made a mistake in here. Modifier dependency loop. Yeah, because when I move, that's actually what it's supposed to be doing. But when I move the root, at the moment, nothing's hooked in. So that's the left leg's got to be going to the root, but the left foot also has to go to the root. And now something has. Yeah. Yep, let's try that. There we go. Thank you. Excellent. That's what we're after. That's what we're after. Okay. And then the knee control also needs to get parented into the root. Put that down back there at the bottom. There it is. All right, so the question that was asked, can you do both legs simultaneously? Let's find out. Okay. There's something that's new, so I am totally going off the reservation here. I have no idea if this is going to work, but we're going to throw all caution to the wind and see what happens. Okay. And there was, and I got to remember where I saw it, there was a duplicate hierarchy. It was in the duplication tab. That's what it was. I think, yeah, duplicate hierarchy. So let's see what happens here. Actually, is there a mirror hierarchy? I saw that somewhere too earlier. There's duplicate hierarchy. That's just going to make a duplicate in its current location. I don't necessarily want that. Duplicate hierarchy. Do we need any tool options for that? No, we don't. So there's nothing that says you couldn't. Well, here's what I would actually do, to be entirely honest with you. I wouldn't duplicate all the leg bones, but I would go in and add in all the IK handles and all those control surfaces for the other side of the leg. Setup tab. Maybe that's where I saw it. Mirror hierarchy X. Thank you, Mr. May. That's where I saw it. Thank you. You've been promoted to Alex number 1. Don't let it go to your head. Yeah, so it kind of worked. It did what it was supposed to do, but since the left foot control and the knee control are outside of the hierarchy that I was mirroring, it didn't exactly generate the result that I was after. I'll have to play around with that some more. This, to be honest with you, this is something that's new that I just noticed in 701. So I'm not entirely sure. Well, mate, let's try selecting everything first before I really say you can't do it. Say again? Maybe that's it. You know, one of the things that I've learned about rigging is that there's absolutely an order of operations that you have to follow and for things to work. So, yeah, there is an order of operations. You have to do it in a specific fashion, or otherwise it's just going to completely just. Yeah, it's not easy. A lot of steps. Okay. All right. Here's what I want you to do for this week for your homework. Okay. I want you to get your rig to kind of this point, okay? Infuse the IK handles, start adding locators to control your feet, okay? You're not going to turn anything in, okay, because we're going to continue to build upon this next week. Kind of tackled the, below the waist today. Next week, I want to tackle all the stuff that we need to do above the waist, to add some control surfaces in there to give us controls over the arms, the fingers, and the head, and all that jazz, okay? Yeah. Couple weeks. I'll let you guys know, and I'm going to give you some love too. As I was preparing today, I was reminded of the complexity of this entire process. So I want to give you guys a cheat sheet. Yeah, in a couple weeks, I'm going to give you guys a rigging test, where I'm going to give you a character, and you're going to rig it. Fill in the dots? Yeah, no way. A Scantron test? Okay, can you even buy Scantrons on campus? See, maybe I should make you guys go get like one of those blue books and like write an essay on how you feel about rigging. No? True story, true story. This is such a weird true story. Thinking about blue books. When I was in college, one of my professors talked about their experience doing all their school shadowing for their teaching credential. Because when you become a credentialed teacher, you have to go spend a lot of time in classroom, watch the performance of the teacher, and then participate as well. And then at the conclusion of that period of that teaching, that school shadowing period, you have to write a big thesis on your experience and all this and stuff like that. And I remember one of my professors mentioned that she was assigned a kindergarten class. And this professor was very pragmatic. She was a numbers gal, right? So she had kind of a mechanical mind. And when she got assigned a kindergarten class, that was like going to hell for her. I mean, she absolutely hated every moment of it. And she mentioned to me that she got back from her experience in classroom for over a couple months, and she had to write this big paper, and it was like the entire part of her grade was this thesis paper for her class, right? And she struggled with this paper for weeks, and because she just had such a negative experience about every single moment, and because she hated it. She hated it. She was horrible at it. She didn't understand kindergartners whatsoever, and she just sucked at it. And she said she sat there for weeks trying to figure out what she was going to write, and then the night before, she was cramming, as all of us do the night before papers do, right? And she couldn't come up with a single good thing to say. And at the end of the day, what she wrote in her blue book for her or not a blue book, but for her paper, she had a very nice cover sheet. And then you opened up her paper, and on the body of her thesis paper, it was one line that says, "I hate this. I'm never being a kindergarten teacher." Okay, period. And she handed it in, and she's like, "I'm going to fail. I'm not going to be a teacher. This is the waste of time." And then she got the paper back for her instructor, and she got an A+ on it. And she said, "Don't worry, we're not going to make you be a kindergarten teacher." And I thought that was just absolutely fantastic. And from that experience, I took away knowing that you learn a whole bunch about the things you hate. Usually in the experiences that you just have a horrible, horrible time in, you learn more about yourself and more about what you want to do than if you just hung out with all the people that you like and having experiences that you already love.
Wow.
So if you hate this, don't worry. I'm not going to make you do this again. Just get through it.
Kindergarten?
Huh?
You only get a blacklist for kindergarten?
Right. Everything you need to know about life and learning kindergarten. Although I would love to teach kindergarten. Not that I don't like hanging out with you guys every week. I love teaching, especially here, but having a 1-year-old son at home definitely kind of draws focus to the problems of a kindergartner. Yeah, right now. It's like, yeah, I know. It's just their problems are so much easier and so much more fun to deal with than our problems out here in the world of adulthood. It really is. Like their problems, as a kindergartner, their life-crushing experiences are when they don't get their favorite crayon. I mean, come on. I can deal with that. That'd be awesome. That'd be awesome. And what little people say is just fantastic. I love it. Anyways. If I could do this all over again, I'd go back and be a kindergarten teacher. Anyways. Okay, so massive tangent. I apologize. So what I want to do for the remainder of class is just kind of open it up for an open lab time for you guys just to get your hands dirty with this new stuff and see if we can resolve as many of the problems with these control surfaces as we can. Okay, I understand that rigging is tough. It's going to need some assistance from the people in this classroom and by me just to ensure that we're hitting the right buttons and getting the sequence in the right step. Okay? Sound good? All right, let's get to work. Let's do it. I love it as boom, 8 hands shoot up all at the same time. Let me stop the live stream real quick, guys, and then we can get back into it.